what I want to transition to is a bit about not only production, right, but what is some of the testing? What are we doing in production to ensure that it's consistent, it's meeting spec? Again, a lot of where your job descriptions come in, as I understand it, right? So let's start with quality control, right? What is, if you're performing a quality control function, all right, what are you doing, all right? And so what I like to emphasize is it's not just about the mixture, okay? It's not just about the end mixture and seeing where that's out. It's about the constituents, kind of like I talked about. It's some of those common pain points. Am I using the right binder? Are my aggregates consistent? Are they kind of going in consistent? So what does that include? That includes looking at my aggregates. Are they visually the same? What is their moisture content? We've already talked about that at length. All right, their gradation, their specific gravity. Understood that you are kind of, you have to use naturally occurring materials in a lot of cases, gravels, etc. But still, I want it to be as consistent as possible. It's not just rock, okay? On asphalt, okay, the asphalt, again, I want to make sure that the delivered binder is what it should be. Again, if I'm in a more remote location, the potential for switch up is probably less here, okay? Tank sticks for binder usage quantities, all right, to kind of gut check whatever testing I'm doing and monitoring any additive usage. And then the plant process. Is the plant running, all right, as I'm expecting it to? Do I have any warnings? Are my cold feeds and belts working? The loader, dust return, my temperatures, all of that, all right, are clues into, am I doing things well, all right? And I just want to address, I see a question from Brian. I'll address your question in a moment, Brian. Let me get through a couple things here and I'll find out a place to kind of get into it. Thank you for adding a question in there. So, in quality control, I kind of get the question of, well, why do we worry about the constituents? You just worry about the end product. I'm just going to test the end product. Okay. So I've kind of have a response to that. My response is the plant does not smooth out things that it's given. Okay, it has a small ability to in some cases, but largely, if you give it inconsistency, it gives inconsistency out. So garbage in, garbage out. Okay, it's not going to fix issues that are going into the plant. Okay, if I give it binder that's all over the place, if I give it moistures that are all over the place, if I give it aggregate and wrap that is inconsistent, right? It's going to be very hard for the plant to smooth that out, all right? It's there to mix, it's there to heat, it's there to dry, right? It's not there to make up for issues with the constituents going in. So garbage in, garbage out, or a more technical professional way of saying it, the quality of the output is dependent on the quality of the input. All right. If I don't have quality going in, it's not going to smooth that out. Okay. I would say it's not like a paver that I give it material and it's going to smooth out the underlying surface a little bit. All right. I need consistency going in. So that's where, from a QC perspective, not necessarily the owner, not necessarily North Dakota DOT or any of the others, right? They may not care about this as much, but the contractor, the people making it, have got to worry about it. The other thing is, if I have mix coming out and it's not meeting spec, and I don't know anything about anything going in, what do I do to change? What do I do to prevent it from happening in the future? I'm flying blind, right? Okay, that's where this is important. So what might you be doing in quality control? What are the tools available to you for mixture testing, asphalt content, gradation, bulk specific gravity, maximum specific gravity, kind of our standard tests, if you will. Okay, might be done in a quality control environment, maybe some, maybe not others, okay, to get a handle on what the mixture is doing. But again, that might be in addition to items I'm doing on the constituents. I put in a couple slides on control charts. And so before I get that, I'm going to hit Brian's question before I get this topic. So Brian asked, when using wrap from milling the existing roadway, have you seen any benefits to requiring that material to be crushed to a 1/2 inch or 3/4 max size before adding it to the mix, providing a more uniform from showing up on the roadway or chunks? Brian, to answer that, in my experience, yes. In my experience, my wrap, if you will, if I'm using wrap, I want for the max size to not exceed the max size of the mix that I'm in at a very minimum. Okay. So if I'm in a 1/2 inch nominal maximum aggregate size, I don't want to see any materials greater than a 3/4 inch in that wrap source. Right? It's going to cause issues in my mixture, chunks coming through, etc. Maybe that's crushed, maybe that's screened. All right. At the very least, a lot of plant facilities might have a screen on there for the wrap source to prevent some of that oversize coming in. But yeah, I would completely agree with that. You don't want oversized chunk material coming in from my wrap source. That should be prevented. Should kind of be like an aggregate, so shouldn't have any oversized material in there. I don't know if you have a follow-up question on that, but I would agree to that, in my experience at least.
No, that's good. Thanks for the info.
Yeah, no problem, Ryan. Awesome. I think an underutilized quality control tool, and I don't know how much it is used in North Dakota, but I always talk about it because I think as an industry we don't use it enough, is control charts. Control charts are a way to plot measurements, the test results that many of you generate, as a way to make better decisions. Okay. So here's the way I would say, here's what control charts prevent you from doing. Too many places, and I guess I just ask yourself, is this you either as a contractor, etc., they just react to the last test. Okay. I did a test, it passed. I'm not making any changes. I did a test, it passed. It's getting finer, maybe on a sieve, but it passed, so I'm not making any changes. Test 3, it failed. It's too fine, okay? Too fine on a couple sieves. All right, I'm going to make a change, right? Okay, I go to the next test, all right? And control charts is a way of combining multiple results together to make better decisions. When you react to just the last test, you have a couple problems. Number one, you are waiting until having failing material to make changes, right? There are ways to find that out before you ever fail, all right? To see trends before you ever fail. Control charts allow you to do that. The second thing that I would say is that you end up overreacting to just chance and random stuff. Okay. You might get a weird result. You make a reaction. You overcorrect, if you will, almost like you do driving. If you go off the soft shoulder, you overcorrect the left. That's a common traffic pattern, all right, and cause of accidents. So we overcorrect. We can often overcorrect to one result. Control charts prevent you from doing that. Okay. So again, what control charts are, they're plots of measurements or test results, help us identify variation. And what the real purpose behind it is to assign something to a chance cause or an assignable cause. Chance cause is what happens. I said we have variability in our materials, right? We have variability in our process. You go to an asphalt plant facility, I'm pretty sure that you're not going to tell me that it's a tightly controlled environment like it would be in some manufacturing plant somewhere. All right. So our job, especially in quality control, the people who are making the decisions on what to do, on what change to make, right? Okay. They need to know the difference between something that's just something by chance and random, or is it something that it requires me to do something? So again, if you're interested, I actually have a little 2-page thing that maybe I can put into the chat that I created on control charts, and as a contractor once asked me about using them and gave a little guide. But really what they are is you take your QC results. These have to be random results, okay? randomly generated, randomly sampled results, and you plot them one after another for a given mixture and plant. Okay. And you plot it over time. And what you can do is it has statistically derived control limits that are based on your material. They're not in an NDOT spec, all right? They're based upon your material. So you use your own data to create these limits. And what they can is with what they've done, and you don't need to worry about how they got there. But with statistics, they developed these rules of warning and action limits. Okay. Warning limits tell you, something might be going on here. Action says you got to do something. You got to do something right away. Okay. So it helps you determine if your process is under control or is it out of control. The distinction there is under control or out of control has nothing to do with meeting the spec. Okay. Contractor's job is also to keep the process under control so that it is predictably going to meet spec. If it's out of control, then I don't have consistency and it's not going to matter. I'm in trouble either way. So this is an example of a common control chart we talk about for volumetrics. All right. We have the 3 different aggregate gravities that you can have. Right. We commonly use GSB, all right, for our calculation of volumetrics and VMA, etc. GSA is when I don't consider any volume of water absorption. All right, I'm sorry, I pointed at the wrong thing. GSB is down here, GSA is no water absorption. GSE is something I can calculate from, it's the effective specific gravity, all right? And so that I can calculate from maximum specific gravity and asphalt content. So what I can do is plot it and I can calculate it with samples. And what we know is it should be in between these 2 numbers and it should be consistent. Consistent and it drops. What matters here is a change. What I'm looking for is changes. So I have a couple real things of real data, okay? So this is an example of a control chart on binder content, right? Test for binder content. All right, they have their target, which is the green line. All right, they have the mean of their data. All right, warning limits and control limits. And what control charts have is they have all these rules that you can follow to identify something that I should react to. So an example is one test result outside of a control limit, 3 standard deviations away. Okay, that's something that's real. What the statistics are telling you is that's a real problem that's far enough to react to. Okay. So I just want to point out the difference here. Okay. Here my aim is 5.6% asphalt. That's my target. Okay. The control limit is down at 3.4%. Okay. So it's saying that you shouldn't overreact to one test even at 4.5. Okay, now this is just example data, right? But what they're kind of saying is at this point, you know something happened here. Something happened here. But if I'm down in this area where my red pointer is, maybe not. Maybe not. Okay, you see no spec limits on here. This is about having a process that is in control, that is around the target and has low variability. That's what a control chart allows you to do. Okay, so I'm not just overreacting to one test over another. Okay, they have all sorts of different control charts. This is one I also like. This is binder content versus maximum specific gravity. All right, 2 common things that we test for. And what you look for on this one is that it's logical. And by logical, it means the more asphalt I have in a mixture, okay, the more asphalt I put in, the less rock. Less rock means my maximum specific gravity gets reduced. Rock is heavier than asphalt. Okay, so this number should go down when asphalt goes up. Opposite. If asphalt goes down, this number should go up. Okay, so it's actually a way that people look at their test results to make sure that they make sense. Okay, so in this case here, okay, the plot, my asphalt content is going down. My maximum specific gravity goes up. That makes sense. Okay. Some people use it to kind of diagnose their own testing results. right? So as to not overreact to what could be a quote bad test, right? A flyer, what other terms that people use to kind of throw out a test, right? Which generally we shouldn't do. So I could speak for a long time on control charts. I'll drop a document in here once I stop speaking. If you're interested, you can reach out. These are really underutilized. If any of you perform QC at a plant facility, then I think you should be doing control charts. You know, it used to be one thing when we didn't have software that could automatically do this. We now have software that can automatically do this. Dustin, your question was the x-axis. Yes, that's the number of tests. So what you do is this is my first test, my second test, my third test, my fourth test. All right, these are all randomly done, okay, at the same frequency. Okay, so that's a key principle of this. And what you would do is plot the last 20, plot the last 25. There's many different versions of control charts. Some of them have an average, a running average. This is a single test, all right? But I would just plot the last 20 I've done for this particular mixture at all times, right? And so once I get past 20 or 25, this one falls off, okay? But what it's telling me is, again, how this mix is producing so I can make decisions that aren't just sample to sample. All right, let's transition to the acceptance function, right? Many of you probably are in the acceptance function at NDDOT laboratory or something along those lines. This is often more focused on the end product because, again, the agency isn't controlling making the product. They just want to know, does it meet spec or not? Okay, so this is done through sampling inspection of the production process. Here I have a good picture of sampling from the windrow, right? Okay, bring it back for some testing, right? Make maybe gyratory pills, etc., whatever the case may be, and looking at this. Acceptance course, another example of an acceptance function. So in this case, samples should be taken on a random basis, all right, based on whatever established test frequency you have, all right? They should be completely independent of what the contractor does, all right, and completely random. The owner, the agency, they're buying it. They have a right to sample at any time. Okay. Samples are then identified and processed and then tested and reported. All right. Whatever using quality characteristic that you use. As I remember, you know, I think you're using, I think you do asphalt content of the plan. You do some gradation. You're obviously doing in-place density, air voids, etc. And at the end, your job is those test results are going to result in quality measures and payment. Right? How much pay am I going to get? Okay, based upon this. And that's your function. That's how important it is. So for those of you that test, right, what I think, again, I've worked in a lab. All right, I worked in a lab when I was younger, in grad school and stuff. I understand the monotony of testing. All right, that you kind of do the same thing all the time. Kind of feels like it's kind of just going, I'm just getting results and it goes out into the ether. What I'd ask you to do when you're getting that feeling is figure out how much material, what's the cost of material that's represented by that sample that you tested. Okay, so if it's a sample that represents, I don't know, 1,000 ton of mix, and let's say that mix cost $100 a ton. Okay, whatever it is, total mix cost, right? That's a test that represents $100,000 of publicly bought material. Okay, that's a big deal, right? So don't think that your test goes nowhere, etc., because it really does matter. So that ends kind of what I was going to talk about with production. If there are any questions, you can certainly ask as well. I do have some slides as asked. I was kind of asked to speak a little bit about a balanced mix design, as this is kind of a new topic in asphalt mixtures and something you're probably seeing more of, as you have a very North Dakota is very lucky to have a group that is trying to keep you on the forefront of getting better asphalt mixtures, again, with Tyler, Aaron, others at your materials facility. Not seeing any, but that is fine. So I'll move forward with some BMD discussion. Okay. So BMD is kind of the hot topic within asphalt pavements. So, oh, go ahead. I'm sorry. Didn't see you there for a second, Gabe. Go ahead.
No, it was kind of late. In your experience, what I know there's all those places you've talked about can cause variations in like
Sure.
a mixed design or something. But in your experience, where have you seen the majority of issues fall in above the rest? In my experience, I don't know if it's biased because I work more with the aggregate side of stuff,
Sure.
but it seems like, in my opinion, what I've seen is most, and that might not be much, happen on the aggregate side. And if you could pay attention to that, it helps alleviate any pressures later on in the process.
I think, again, it very much depends on where you are, Gabe. I would echo your sentiments. My garbage in, garbage out slide is a mentor of mine, Rick Bradbury in Maine, who worked there for a number of years, kind of was around when they first instituted QA specs. We would always say, in talking with him as well, that we would almost rather the contractors not test the mix at all. Just test and worry about what goes into the plant. Their aggregates, their wrap, their binder, again, if you have multiple sources, all right, and worry about binder management and all that. But I would agree. I think a lot of issues start at aggregate inconsistency, be it aggregate gravities, be it aggregate gradation, be it wrap gravities, wrap gradation. I think I would generalize it to be what I would call the constituents. I think a lot of our issues happen there, before we even get into a plant.
Okay, thanks.
Yeah, no problem, Gabe. Excellent question. Any others before I move forward? Okay. So, just a little behind the scenes on BMD and what maybe more of what I'll talk about is a little bit more why you might be seeing work on balanced mix design in North Dakota and other areas. Okay, because and what's behind that. So I always ask, how do your pavements fail? Do all your mixes perform equally? Do you think your specification optimizes mixtures? So often for those mix designers in the room, is 4% or 3% or whatever air void's the same? And is that needed for every mix? And when you do put a given mix out there, a 12-5 surface, whatever it is, okay, around the state of North Dakota, wherever you are, right, or any of the Dakotas, do they all perform exactly the same? And I always get the answer, no, of course not. Okay, no, they're different. Well, your spec is treating them as equivalent products, if you will. Okay, and we know they're not gonna, but that means we're missing something in our testing, in our evaluation, in our acceptance, in the way we spec materials. We are missing something, and we as a field have been trying to close that gap. And I would argue that balanced mix design is our aim to close that gap and capture what we're missing in how our pavements fail today. And so if we step back and think about what are we trying to do when people do a mix design, I guess while I'm speaking about this now, if you know how and can raise your hand thing, there's a little raise hand button for the people who have done a mix design themselves. All right, either currently in your job now or, in the future. I've done one, too. All right, done a bunch. Okay, so we have a couple mix designers in the room. Thank you. What are you trying to do? Okay, as a contractor, you're trying to meet the spec. All right, but the spec is trying to get a durable, good performing, and cost effective mix, right? That's what the spec is attempting to achieve. That's where the spec requirements come. And then you as a contractor are trying to design a mix to meet that specification, okay? So how we largely do that today, for those that maybe don't eat, breathe, live, asphalt mix design, okay? How we largely do that today is start by selecting materials. aggregate asphalt wrap. Okay. Especially, I would say for regions like North Dakota. Okay. Other areas can maybe pull aggregate from different areas and stuff like that. Often you have a pit, you open up a pit. I've got to make a mix out of this pit. I've got to make it out of these materials. I don't have the flexibility to get materials from somewhere else. Okay. In a lot of cases. Now, given my materials that I've selected, I'm going to pick an aggregate structure. Okay. We often talk about the aggregate as the skeleton of our mix. All right. The asphalt is the muscles or our tendons and all that. Right. Okay. The skeleton of our mix is that aggregate structure. How am I going to blend these aggregates, rock, sand, wrap, etc. Okay. To meet the needs. Then what we do is we do a volumetric design. And big word, all we mean is that we used to design mixes by weights. Okay. I'll put in 5% of asphalt by weight to every mix of this size, or 6% asphalt by weight to every mix of this size. And why that doesn't work, why we do volumetrics, is because the coating, how the asphalt coats different aggregates is different, and how it gets absorbed is different. You have some very, very highly absorptive aggregate within your region. Okay. We don't like highly absorptive aggregate because when I coat it in asphalt, it sucks up the asphalt. And that asphalt does nothing. Doesn't provide me a single thing, but I have to deal with it because it absorbs the asphalt first. It can't coat the rock until it absorbs the asphalt, and it's done absorbing asphalt. Okay. So in that case, right, that's wasted asphalt. So if I put 5% asphalt in a bunch of different mixes that had different rock, even if it was the same gradation, the amount of effective asphalt is different because I have different absorptions. So the amount of asphalt that's actually working to get performance is different. That's why we don't do things by weights, okay, anymore when we design. That means we do it by volumes, okay? Because the weight of asphalt that's absorbed, it still counts as a weight. But when I do volumes, we don't count it. We are able to do math and do all of these gravities and volumetric calculations to not count the binder that is absorbed into rock. That is why we do, quote, volumetrics. Okay? But largely what we do there is we say, given these materials, given this aggregate, pick the right amount of asphalt that's going to work for this mix. Okay? That's really what we're doing with volumetrics. Right? Pick the right amount of asphalt, put the right amount of glue. You won't hear me say oil, okay? We don't say oil where I was raised, okay? We say asphalt, right? And then maybe I'll do some testing at the end, okay? That's generally what we do today. So we have all these equations, VMA, all right, VBE, all right, all these different things that volumetrics largely focus on the concept of how much asphalt is right for your mixture. And the thing is that that right amount of asphalt is contingent on many things staying the same, including gradation, dust, absorption, gravities, angularity, gyrations, etc. And the principle is that air voids controls the right amount of asphalt for a mix, where we largely say 4% air voids, that's the perfect amount of asphalt for that mix. Here's where the flaw starts to come in. We say 4% air voids or whatever it is the right amount of asphalt for every mix. Every single mix. Okay? They're all the same. And I think our experiences showed us that that's not the case. Okay? So what has changed and why are we talking about something new? All right. What has changed is that we can do testing of the resultant mixture. I gotta do it in my prop. Okay. Of this puck. All right. I can take the end product, the mixture, and poke it, prod it, pull it, load it, etc., and see how it behaves. And that will tell me something about how it's going to behave in the feed, more than what these volumetric properties might tell me. Okay, we used to have testing like this, but it wasn't practical. We couldn't do it in any old lab. You had to have a PhD to understand it. Okay, well now we get to the point where you don't need that. And that's what balanced mix design is. So when you hear, people from your materials bureau, right, all of that talk about balanced mix design. Balanced mix design is a philosophy, All right, that big long definition. Unfortunately, I was part of the people that wrote it, so I only have myself to blame for a big long definition. But it's a philosophy too, and I think the verb I like to use is optimize. We want to optimize the mix performance against how it's going to fail. And here's the thing: it's going to fail different in Minot, North Dakota versus, I don't know, Clearwater, Florida. Okay. They're going to fail different. You have more thermal stresses. You have thermal cracking. You have less traffic, but a lot of cracking issues, right? Other places have to worry about running more, etc. Okay. BMD, balanced mix design, tries to accommodate for that and say, I want to optimize it against how it's going to fail. Running, cracking, moisture damage, right? Raveling, the different types of cracking, etc. And that's what we attempt to do. The other thing with balanced mix design that we try and do, in what the goal is to remove requirements, right, that don't adequately predict performance and give the contractor flexibility, kind of like I've been saying with QC and acceptance all morning, right? Is that we want to allow the contractor as much as possible to control their materials, their product, their process, okay? As much as possible. We can't completely let go, all right? But we want to allow that flexibility. Well, what BMD is showing is that maybe you don't need to specify air voids, right? Maybe there's different air voids that give me performance. Maybe there's different aggregates. I know fine aggregate angularity is a big thing within your specification, right? You have different fine aggregate angularity mixes, right? Higher the fine aggregate angularity, the more traffic, more rutting potential. Well, what BMD may allow is that maybe there's ways to achieve rutting resistance without speccing the aggregate, okay? That maybe I can have a more rounded aggregate, but make up for it in other ways, right? Which allows innovation, which allows cost effectiveness, and still hopefully gets you the performance. That is the end goal of balanced mix design. So there are 3 tiers, if you will, to balanced mix design. This is a newer slide, if you will, of something I've been working on, that as people move towards further balanced mix design, what's going to happen is relaxation. Okay, so from my contractors in the room, tier 1, all right, tier 1 BMD, kind of the initial BMD, is maybe just adjusting volumetrics, okay? Allowing maybe a range of air voids. So you don't have to design to 4% or 3.5%. We'll give you a range, 3 to 5. Design anywhere you want in there, okay? Tier 2, you start to relax even more, okay? Which means at least 3 relaxations, volumetrics and constituents. All right, so again, for your situation, maybe that's fine aggregate angularity. Maybe there's a reduced expectation for fine aggregate angularity, some volumetric relaxations. But again, you've got to meet the BMD spec. You got to meet a rutting test, a cracking test, a moisture damage test, whatever it is. And then what we're hoping for the future, maybe this is 5 or 10 years from now, is that we eliminate nearly all of our other requirements besides these tests and really allow maximum flexibility. So if you want to use a polymer modified binder to get there, fibers, a different aggregate source, a different type of mixture, you're allowed to do it, right? You have the flexibility to do it. That's the kind of vision to tier 3. And so I have just a different slide to show the same thing, that when we're talking about this, we have different performance characteristics that we care about: rutting, cracking, moisture damage, surface characteristics, whatever it may be, okay? And what we want to do and what states are trying to do is move from tier 1 up to tier 2 or tier 3 to relax. That's where we get the cost effectiveness. If I don't relax, then I'm taking a target and I'm making it smaller. For those of you that are mix designers, that are contractors. So that's one of the benefits that we're hoping to get through BMD, and that's where some of the work that's being done on BMD is aiming to achieve, right? So when you see, I know, North Dakota's looking at the ideal CT, all right, for cracking, maybe the DCT for low temperature cracking, Hamburg wheel tracker, okay, for moisture damage and rutting potential. These tests, I know often we kind of think, oh, it's a new requirement. Well, the goal is to implement a new requirement to let go of some of the others, replace it, if you will. Okay, to allow flexibility for mixed designers to effectively use the materials that you have available to you. Okay, and so that's a lot of the motivation, and North Dakota is not the only one. All right, nearly, I would say, I don't know, I'd say 85% of states are investigating implementing BMD in some form or fashion. I think it's going to reshape the way the mixed designs and the testing that we do over the next 5 years or so. So that's my last BMD slide. I did put the same ones on polymer in here. I think that kind of keys in. So I'll keep going on this real quick, and then I can pause for questions as I'm almost out of slides. So polymer modified asphalt mixes. I know you're using these a little bit more. Again, I showed this video yesterday. This is me pulling a heavily modified binder apart, and it elastically recovers. You do this with a non-modified binder, and it's not recovering. It's not going to bounce back, if you will. Okay. And so I have these slides just to talk about producing it. It really increases the elasticity of the asphalt binder, the bounce back, and the mixture. It's something that can help in rutting and cracking. The thing to acknowledge is sometimes that mix could be a little stiffer and stickier. All right. For my people and the placement folks. All right. But really, polymer modification has been something relied upon by many states, many owners, contractors to get added performance. Things to watch for in the field. I noted this yesterday, but I do think it's important. You know, it's important enough for everybody. It can result in some changes in workability and compaction. All right, rubber tire pickup, some of these things. Just knowing, you know, that it might feel a little bit different, but I'm guessing that once you all kind of get used to working with it, even in the lab, it's really not that much of an adjustment. Often producing and compacting is done at higher temperatures, so considering a warm mix additive is a good thing. And then really you don't want to touch it in the field. All right, same thing in the lab, you got to be real careful about handling it, etc. So I have a couple more slides and I'll wrap up, and I'd be happy to answer any questions that people do have or topics people would like to cover. I guess before that, yeah, Dustin, good question. Most people, Dustin asked, what tier are most people at right now? And I would say tier 1. All right, we have a couple states operating at tier 2. All right, I think that you're going to see many go from tier 1 to tier 2 again over the next couple years. There's a number of kind of lead states on BMD that I think are in this tier 1 and almost in tier 2 level. No one's at tier 3. Tier 3 is more of an aspirational goal. We hope we can get there. We'll see. Okay, the science has to kind of show that that's possible. Yeah, no problem. So just a couple things to take away when I thought about it for those of you that might be mix controllers, right? You're controlling the mix in some way, shape, or form, whether that's acceptance testing, whether that's for the contractor. Not just about striving for meeting specifications, strive for consistency. You don't have quality if you don't have consistency. Okay, that's a principle by which I strongly believe in, that I need consistency to have quality. Consistency doesn't guarantee me quality. I could have consistent garbage, okay, but I can't have a good product if it's not consistent. So production is really about striving for that consistency. That's where control charts and your kind of concept on QC is very important. Understand where you fit in this process and don't confuse it, all right? The owner, you are accepting the product. That's the end of your responsibility. The inspector, what you're doing out there, QC, etc. This third bullet has been reworded many times. It's often on a towel that hangs in labs that have been. Quality control, good quality control reduces rework and produces better pavements. Otherwise said as, you know, good quality control is cheaper than remove and replace every time. All right. Having good quality control practices, all right, may cost some money and some effort. All right. It does take some effort, but it's cheaper than remove and replace on one job. Right. And BMD is the future. Balanced mix design promises to bring us better performing pavements to handle the future where we face, you know, aggregate issues, getting aggregate, whatever it is, we have to deal with newer materials. I don't know if many of you heard, but everyone wanted to put plastics in our asphalts for a number of years, and that was a hot topic. So whoever comes up with something they want to stuff into our roadway materials, we got to have something that handles it, and I think balanced mix design will be that for you. I did include the inspector checklist that I gave yesterday for those in the field. Again, I think it's important for everyone to see this. I just made this as an idea of things to look at if I'm an inspector in the field, no matter what you're doing, QC or acceptance. So that'll be in the slides as well. And then if you're an inspector anywhere at the plant, all right, on site, I kind of think of this stoplight analogy for thinking about it. This is your decision guide. If I'm in the green zone, I'm observing and I'm documenting, and you could add for my testers, testing, right? Yellow, something's going wrong. I'm going to document what went wrong, maybe the test result. I'm going to verify, all right? I'm going to notify somebody. Hey, we got some sort of issue, all right? What is my corrective action? What am I going to do? And then red, if things are real bad, stop. All right, if we got a real problem, let's stop and let's talk about it. And I think that applies no matter where you are in this process. So with that, I'm going to stop there and see if there are any questions, thoughts, topics you want to cover. I do have other slides if people want to hit on a particular topic, but I figured I'd stop there for now, Sharon, and see. We've been almost 2 hours and see what people want to talk about.
And we also, I believe Tyler Wilmoth is still here. So if anyone has a real pointed question for what North Dakota is doing, it's a good time. Or Tyler, maybe you could just, if you are, I believe you're still on, give us a little bit of an update.
Yeah, I can jump on, Sharon, and share a few things here. I guess if we get tight on time here, let me know. But yeah, Sharon brought this up, and I know that Aaron Perez did a video, and I think that was part of your homework for the class today. So some of this was probably covered in what Aaron did, but I'll just bring this up in case there's any questions. Just wanted to go through a few things that we'll be working on here the next couple years as far as kind of new things and different pilot projects we're going to be working on. The first one was bid here a couple months ago. That's on Highway 1 in the Devil's Lake District. That's an full depth reclamation with emulsion stabilization. So we haven't used the emulsion stabilized base up to this point. It's something that some other states, have been successful with, and we wanted to try. So we came up with a special provision for that, and the first project will be happening this summer. We have a high wrap project with balanced mix design that just got bid last Friday. That's on Highway 18 in the Grand Forks district. So we've done a couple of these high wrap jobs in the last couple of years. What we define as high wrap is 35%. We haven't really made any changes other than telling the contractor to use 35%. So this is kind of the new one. There's two things kind of different here. One, we're asking for the contractor to add a recycling agent to the mix to help soften some of that wrap material. And then we're also going to be doing BMD testing at mix design, and we're going to help set our asphalt content based on balanced mix design tests. So we'll have the contractor run a standard volumetric mix design. They'll send the mix to our central lab here in Bismarck. And then we're going to run rutting and cracking tests at some different asphalt contents, kind of starting at optimum and moving up from there. And then we're going to set the optimum or the target AC based on those tests. So it's kind of a hybrid of what Derek just went through with Tier 1, where we're still using the volumetric mix design, but we're going to use BMD to try to optimize that. Another kind of thing that'll be not 26, but 27 is our balanced mix design pilot projects. So we did our validation test section project 2 summers ago now on Highway 14. And Derek was actually got to be kind of a part of that project and developing that up to when that was built. This one is kind of similar. We're using a stakeholder group, some different contractors throughout the state. We have a couple mix designers in there. But that'll be kind of our first rollout of some balanced mix design projects. And those will be bid for 27 construction. Highly modified, been kind of a buzzword here the last year or so. Utah has done a lot of this. There's some other states that have done different variations of this. We're more interested, I would say, in the Utah version. We have a project that'll get built hopefully in 27 that'll use that, and looking for some other projects throughout the state, kind of higher traffic type projects to do that on. So something we'll dip our toes into there as well. We've done some of these thinner overlays on our 1804 test section project, and we're looking for a few projects to expand on this. 9.5 is kind of new to us. It's not really new across the country. There's some states that kind of their main mix that they use now is a 9.5 mix. So it's new to us, and it's a little different for crushing aggregate, but I think it's kind of proven out already that it's a good performing mix. I'm just highlighting that emulsion FDR. We also went through and kind of redid our special provisions for FDR and cement treated FDR, just so that those three things all read the same. Here's the BMD stakeholder group. Just wanted to show kind of who was involved in that at this point. Mike Brever, I know, was on this training earlier, so he's been attending those. We have some contractors. We have a couple of aggregate producers and a couple of our mixed design labs, as well as, you know, a couple of people from North Dakota DOT, and then our research partners with NCAT. So it's kind of the last thing I wanted to talk about. DOT folks are mostly used to seeing this when they do district designs. This is what they use. We've put this out on our external site now, so cities and counties can access this and kind of see how we pick our mix and binder grade type. So we have that out there. This is a draft one. This isn't out there yet. It doesn't include this part in the red box currently, but this is something that we're going to be adding to it this summer, is some guidance on where to use some of these different mix types. So as we get further into balanced mix design, like Derek said, we're pretty reliant on this FAA grade right now. I think that's probably gonna start to change here as we do more with BMD, and we'll probably move more to specifying a mix type based more on the size and the gradation, and not rely so heavily on the FAA in the future. So yeah. Those are the things I wanted to cover, I guess. If anyone has any questions.